Hello, everyone. My name is Nathan, otherwise known as Old Man Builds, and I have Gerald here. I also have the Benny Factor here, and we're going to learn a little bit about a few circuits today. I have a little bit to show. Gerald, how about you? Your mic's off, Gerald.
No, I was just saying maybe. I didn't get my theory done because I've been so busy working on my presentation that I kind of put that aside.
Mm-hmm.
So I could show the circuits that I built, and I might have a video to display about it. So I'll have to look. I know I did a video about it, but so sorry.
Okay. Just want to give a big shout out. Joel's here watching us today. Joel,
Hey,
you were
Joel.
awesome when you came on. Absolutely, everybody loved it.
Yeah, thanks, Joel. That was a really cool show, man.
Yeah, I hear so many good things now. I can't say enough, so I'll say nothing.
All right, guys, I'm going to pull something right out of the archives here for you. It's something everybody wanted me to go over, so I'm going to go ahead and share it. Let's see. Okay, basically what this is we're going to look at changing frequency inside of a circuit. Now, you don't have to use a flyback for this. You can use any coil that you want, and I'll set it up here before we show it. Basically, what we have here is we have a small ZVS. Now, the only thing I'm looking for out of the ZVS is the pulse. So the power is connected to the ZVS. I'm just looking for a pulse rate out of it, and that's it. It goes into the MOSFET, and when it gets there, that's a Z44. So it goes into it. It shows the pulse in there, opens the gate, allows it to go at that pulse rate, right? Now, what I did was I also put on the writer to it, and I'll show it here in a minute. But you have to connect the actual frequency driver with the MOSFET. And all it is two 10 ohm resistors, not K ohm, but just 10 ohms. So you can use a 20 ohm, that's fine. And it goes from the PWM signal from that actual 555 timer that's in the frequency generator. And it goes right into, I believe it's the collector of the MOSFET. And then that allows it to add frequency to everything that it goes in. So it allows you to put frequency into your coil while you're still getting a pulse rate. So this is it's a cheap circuit. I want to say it's under $20 to build, maybe 30 because of the small ZVS, but it works perfectly, and I'll show you right now. So I built a circuit here, and what I'm doing is adding frequency and a duty cycle to this. So that we can change this on our high voltage. And I just wanted to give you a quick show on the audible difference where you can hear the sound. And then as we change the frequency, you're not going to be able to hear the sound. So this is going to be a circuit that we're going to need to put into our gravity flyer on our high voltage. We're going to have to beef it up because I blow a lot of these MOSFETs. So here we go. I'll plug it in and you can hear it. And then I'll turn down the frequency, and you'll hear it differently. So here we are, we're at 2.8 kHz. Can you hear that? Okay, now MOSFET gets really hot at that frequency, so let's turn it down a bit. You can't hear it now. So usually we're running a lot lower than this, and this is at 745 hertz. You're getting what you normally get. Okay, close to this. Now, so I'm just going to stop it right there, guys. You heard the audible difference. Okay, when I'm changing the frequency, all I'm doing is changing the frequency up and down. And what that's doing is it's bringing up the volts, bringing down the amps and increasing the frequency. So that's what happens when you do it. Sometimes it'll be in the audible range where you can hear it. Sometimes it will not be. So this is an easy way to put a PWM signal in there. Now that little generator right there, all digital, tell you exactly where you're at. It cost me, I believe, $8 on Amazon, and it was cheap. MOSFET right there is a Z44. It cost me probably a couple cents. And then, like I said, $20 right there is the ZVS. And then I generally use in this situation 19 volts, 4 amps. That way the amps do not overpower the circuit. And I'm running a flyback in this situation. I need enough amps to get it started, but I want a heavy voltage on it. So that's the reason for this circuit. Now, again, you can put it in any one of your coils. It's real simple. And I'll show you the updated version in a minute. First thing I want to do is just clarify the Z44. On the far left pin, it's a gate. On the center pin, it's the drain. And on the right side, it's the source. So in this, your source is your, source should be, let's see how I set this up real quick so I don't get it wrong. The source is on the right. So that actually is going to go right over to your ZVS. Your ZVS also goes straight over, and it looks like it goes right to your coil. Then the actual drain pin, make sure I got it right. Yeah, the drain pin will actually come out, and it goes, see if I can see this, right to your ZVS. So it'll connect to the other side of that ZVS. And let me play this a second so I get my hand out of the way. And we have the ground that connects into both grounds. So you can see it going there, and that is on the side that's a source side. So anyway, guys, real easy circuit. This is on my page. I will go ahead and give you the reference to it right now. And you can just watch it for yourself at any time you want. But it's an easy, cheap way to do it. You don't have to know a lot about it. Now, let's go to the second one. And I'm going to share another one that I did. This one right here, basically, we're just going to sit there and replace a couple parts. You see our ZVS, we see our flyback. That's pretty easy. Now I'm going to show you without the MOSFET. We are simply going to add a trigger circuit to this. It's really simple. Again, the resistors are both 10 ohms. Same thing, same setup. You can use a 20 ohm resistor here. Let's go ahead and make this bigger, and we'll play it. I want to show you, this is the same thing with the two flybacks on the one ZVS, but this time we're going to add frequency and duty cycle to it. So I went ahead and hooked that up right here, and we're going to run at 2.79 on the frequency. Right now I have it at 0 duty cycle. As I turn the duty cycle on, you'll see the 2 sparks start up, and you'll hear the frequency as well. So here we go. And we're at 59% on our duty cycle now. And it gets a lot louder. We'll go up to 80. Go up to 97 and went down in volume. So right around, let's see, around 50%. You hear that? I think the inconsistencies in this right here, you see it sparking a little over. So here we go, guys. I'm going to show you the circuit here. I don't know, well, you can see this right here, but this is what I was running at, 2.79. Okay, so this right here, we just have a power pack. Let me pull it out. I'll show it to you right here. You see that? We are looking at 12 volts, 2.5 amps to run this little guy here, okay, on the low side. Okay, it comes off here. 2 10-ohm resistors. Okay, you can use a 20. I just didn't have one. Okay, I got this right here. This little guy. It actually, these MOSFETs don't blow off. These are power MOSFETs, so they handle more power than the a regular one of these things here. Okay, these things, I must blow up these MOSFETs like a billion of them. Junk. Went to this. It's just a simple switch, so it takes the power, puts it from here to here, and drives it into here. Okay, and you look, it's just a regular ZVS. 2 in, okay, power, and then 3 out. So the way this is wired, okay, the top one, the one that goes over the top, I always do in red, and this one that comes on the bottom, I do in black, just for my sanity. Okay, so that when I wire them up here at the bottom, you can see the 2 reds are on the outside. That's the one that goes over top. The 2 black wires are going on the inside. That's the one that goes on the bottom. And then try to move this out of the way. I don't think I can. But all I have in here, come on. You can do it. Get that damn thing off of there. Bunch of wires, man. You can see in there, I just got another flyback in there and just wired up. I should get a bigger box and divide it so I can run this thing. But it does what we want it to do. So we'll just go back. Switch. So we'll just put it back to right here, guys. This is real simple. I always tell people the power going in on the trigger circuit, and you can see it right there with the black cord that splits off into 2. The power going out that goes to the ZVS. That's just a solid connection. It's as easy as it can be. It's just splitting the hot wire and the negative wire going into the ZVS. That's it. Or you could say positive, negative, because it is DC. So that's it. Now, the other side of that is just a simple trigger circuit. So what does it say? It says ground on one, and it says PWM on the other. The ground connects straight over from ground to ground. The PWM needs a 20 ohm resistor. The reason for that is in case you get any back frequency. Any back frequency is going to shred that resistor before it goes back into your frequency generator. That's what you really need here, okay? So it's real simple, guys. This is not a hard circuit. You do not have to add a lot of parts to it. You are welcome to add diodes wherever you feel necessary. But this is the basics. Hey, let's get it running. Let's get it up to speed, and let's be done with it, okay? That's all I wanted it to do, and that's what it did. So anything you want to do with this circuit, you want to take your coil, you want to pulse it, instead of playing with an Arduino for 20 minutes and trying to load a program, duty cycle, couple seconds, press the buttons, there you go. You want to change the frequency on it, couple buttons, couple seconds, go ahead and do it. It's real responsive, happens right away, and you'll love the circuit. Anyway, I'll put this one on there as well for you guys so you have it. If you guys wanted to go and check it out, like I said, there's no schematics needed here, guys. It's a couple parts. It's a couple wires. I'm sure you guys can all trace them back. So here we go. And with that, I am done. And everybody, what do you got?
Hey, guys.
Hey, Mike.
Hey, Mike.
How's it going?
Good.
Yeah, I was a little under the weather today, so I took it. Hey, Ben. I was a little under the weather today, so I called in sick. I had a bit of a touch of the stomach flu.
Oh, I'm sorry to hear that. I'm still recovering from something myself.
Yeah, it's been going around. Yeah, everybody at work's been getting it, and so I guess I was next in line.
Yeah, how do they put it? Your turn.
Yeah. Oh, Nathan, I was gonna say, any circuits that you have on the show, I'd like to post on my forum too. So, if you have any like diagrams or anything, any like information like that, just send it to me through email.
Okay. Yeah, you're welcome to all of it. No
yeah,
problem
because
there.
I want to make. Yeah, I just want to make a database so I can go back for myself and be like, okay, so this is, Nathan and Gerald circuit for this situation. Let me see what I can do. So I have like an archive almost.
No soup for you.
Yeah.
I watched that just yesterday.
Don't be a Nazi.
Check this
Oh,
out.
man.
So this is the PWM that Nathan's talking about.
Yeah.
Same
There's a
one,
lot
right?
of good little circuits.
What's the frequency range for that one, that module?
I think it's 3 kilohertz.
Does it go low though? Because mine doesn't go below 1 kilohertz.
Oh, that's interesting. I don't know.
Yeah, it should go down to the hertz. It goes into the
It will?
hertz. Yeah.
Okay, because that's the one I need to get then. I need to get that one.
It was cheap too. I think it was $8-9, something like that.
This is
Yeah.
Some of them are pretty cheap. I got one like $20 and it'll go down to 1 hertz. And then high
nice.
is
That's exactly what I need.
I think 4 kilohertz or something like that. So it goes pretty high.
That's not bad.
Yeah, and it's 3-channel, this one.
Oh, that's
Oh,
3-channel?
Yeah. Yeah.
Oh, nice. Oh, that's perfect for your setup then, Gerald, right?
Yeah, for that new coil that I wrapped for 90 degree out of phase. That's why I ordered it.
Oh, wow. Yeah, you definitely got to let me know how that one works out. That's going to be awesome.
Definitely.
So just to let you guys know, I've been working on my presentation. So probably in the next week or so, we'll make a time, probably on the weekend or something, and I can do my presentation.
Cool.
Awesome. We look forward to it.
So basically, I'm going to go through the history right from Nathan Stubblefield all the way up to Robert Adams, where Bandini
nice.
got most of his ideas from, because that's a big myth. And also Ron Cole was another player in this game that he kind of disappeared and Bandini kind of took over and took all the credit for his stuff. So there has been some kind of controversy, especially with him and Rick Friedrich, and a whole bunch of interesting stuff happened with Bandini. But I'll go through the real history of where the pulse motor originated from.
Oh, the Adams motor?
Well, no, this is going way before the Adams
this is
motor.
before that. Oh, wow.
Yeah. Awesome.
So we're going back to the late 1900s.
That's cool.
Late 1800s. This actually predates Robert Adams. So
yeah, that's a big gray area for me. I need to learn more about that I guess you would call it maybe pre-Tesla era, or that's when Tesla was like at
no,
his best?
I'll do the full presentation, but the guy who actually made the real quote unquote first pulse motor was Nathan Stubblefield.
Oh, that was
Really?
Tesla's protege, wasn't it?
The Stubblefield coil. That guy's famous
Right.
for that.
Okay, he came up with basically the very first pulse motor.
Oh,
No.
yeah, he was a student of Tesla, wasn't he?
No, he taught Tesla.
Oh, he was the one who taught. Oh, so I have it backwards. So he was
Yeah.
the one who taught Tesla.
He was the one
I told
who,
you, this area is a little gray to me.
yeah. So he was a farmer from Kentucky, and he developed these earth batteries.
Yeah.
Yeah,
And
the Earth battery.
As he learned the earth battery, he also came up with the very first wireless phone.
Mhm.
Okay.
Oh.
And around that same time, a lot of buzz was going around about him. Word got out, and all these physicists start showing up. Tesla was one, Einstein was there, and a few others. And they witnessed his devices, his first wireless. And this was where Tesla came up with the idea of radiant energy. So it wasn't actually Tesla that came up with it. He got tipped off by Nathan Stubblefield. So I'll get into that.
Yeah.
Right. I'll get into the history of that and how that all materialized to today.
So I wonder, I don't know how much information you have, but I have a theory about Stubblefield and the Tesla's Wardenclyffe Tower. There's he speaks about how he has mass amounts of copper below the tower, almost in the aquifer.
Right.
And my theory is that it's a Stubblefield coil. It's the perfect configuration And since he was working around them and with them, it makes sense.
Right. And that's where Tesla put 2 and 2 together and came up with the Colorado Springs experiment. He had his own ideas, but he got inspired by Nathan Stubblefield. And a lot of people don't realize that. Yes, I'm not knocking Tesla. Tesla, by far, a genius in his own right.
Yeah.
But there were guys before Tesla that he was looking at. He was watching what they were doing.
Well, Tesla was also inspired by the Sanskrit texts. So,
and the pyramids.
For sure.
Yeah.
One thing that Tesla was a great engineer. He was also a great researcher.
Yeah.
Yeah,
Okay.
I agree with that.
And
he had to have been.
he was also very good with the mathematics, where a lot of hands-on guys as engineers or technicians, they don't have the math background where Tesla did.
And as much as I hate to admit it, that video that came out recently that had to have been approved by the Freemasons, otherwise that information couldn't have came out. They stated that Tesla was a Mason and that he had access to the library. So if that's the case, along with his work with Stubblefield and Einstein, yeah. I mean, he was a genius, don't get me wrong, but he had access to all the top information that none of us.
Very possible. Like, we're just going based off of information that has been published.
Right. If you have access to a document that suggests that ancient Egypt had the ability to transmit energy wirelessly, you're going to think about your inventions a little bit differently. You're going to try to, see how you can reverse engineer that. At least I would try to imagine how to.
But this is where I'm kind of skeptical about, Tesla being a Mason, is the fact that if he was a Mason, why was he stopped? Because the Masons are supposed to have.
Because it's not part of what they were doing. You gotta look at what's the name of that gray-haired bastard that they all worship there, the one on the
JP Morgan?
No. Darn it, I can't remember his name. Scum of Scum. So it slips in one ear and goes out the other. It's like
Heavy side or
no. It's what they worship, that like that thing Harem Abiff that they call their god or whatever they swear an oath to. He's one of those guys, the guy that wrote the letter.
Moloch or whatever.
No. The guy that wrote the letter about the 3 wars that are occurring or occurred.
You're talking about I know who you're talking about. Nostradamus.
No, I'll get back to you. I can't believe I got it.
I mean, I can imagine a situation where Tesla, maybe disagreed with the Masons if he was one and saying, I want to provide energy for everybody, and maybe they didn't want to.
I think maybe that's possible. Maybe he was a Mason and he kind of stepped over the line and he got slammed, basically.
Well, maybe it wasn't time to get the secret out.
Yeah,
it was in its infancy, electricity, and it wouldn't be understood. And it would all fall on deaf ears. So they
That's true.
That's true too. That's a good point.
I have an open mind. I'm willing to listen.
Yeah. Well, there was another rumor that Nikola Tesla was gay.
Oh, let's hope not.
No, apparently they were saying he had a male partner for several years.
Well, honestly, that kind of makes sense because we haven't heard anything about a relationship partner from him. If he made one reference, he would keep it quiet back then.
But it was made one female, right? That he or a female-ish name. I don't know.
I just assumed he had, my uncle has severe, he has high functioning autism. He's, he doesn't have like a libido.
Yeah.
Hey, let me clue you in. I don't care.
Yeah.
How about that? I just don't care.
Yeah, it's irrelevant. Yeah.
Yeah. So, there's a lot of stories, right? But I like to focus on the ones that really matter. So as far as my presentation's concerned, I dug back far enough. And when I found out that Stubblefield was the guy who came up with the very first pulse motor, I am like, aha, yes, that makes perfect sense.
Well, so we have to separate the fact from fiction because, you're going back to the pigeon story about Tesla. That was complete slander, telling us he was in love with a pigeon. He liked pigeons, but it took it to a whole new level to discredit him, calling him crazy.
Metaphorically, people assume the worst It was a metaphorical thing that he loved his pigeons.
Dude,
Right? What a lasting
groundhog in
impression
my
from
back.
that.
I have a groundhog in my backyard. I call him Walter. I love Walter. I feed him every day.
Yeah, I don't know how much truth there is to this or not, but Tesla apparently meditated a lot. And when he did, one of the reasons why he never married is his belief was that if he did, he would lose his ability to have these visions of machines that he was building.
Yeah, he wouldn't be able to devote his time, right?
Yeah. That
Oh,
makes
I can
sense.
tell you right now, women do that to you all the time. Sitting around that. Man,
They slow time down.
I could have saved this world if it wasn't for my wife. Yeah, that's it.
Violation.
If
Just
she
get
wasn't
married.
nagging me, man, I could have made all this cool equipment.
Yeah, I hear that. That's why I got a door, a lock. That's it. I'm working.
A door and a lock.
She's like, I need something. I love you. No.
Oh. I told my wife, I said, God gave me a gift. He made me deaf, so I can't hear you all the time.
Yeah, that's called selective hearing.
Yeah. She's like,
all men have it.
I'm
all
like,
men,
what?
all men have it. It's a natural born trait. It's called selective hearing.
Yeah.
Oh no, I literally cannot hear.
It activates this trait. Selective hearing activates when you say "I do" and you get married. That's when it activates.
Along with the time dilation.
No, it does something to your gene in your brain when you get married. It activates.
Mine activated after my first girlfriend. So kidding.
But yeah, so I'm going to do quite a bit of history stuff. So it might seem like a bit of a drag in the beginning, but really it isn't. It's important to know the history.
You're laying
like
foundation.
History, man. We all like that stuff.
No, I'm excited.
I've studied Tesla quite a bit. I know a lot about his personal history and where he came from, what his parents were like. Stuff that sounds kind of redundant, but actually not, because it's kind of paints a picture on Tesla's character, right? Yeah. That's one thing. We don't have any reference to see, what kind of a guy was he? Like, was he a happy guy? Was he a pessimist? Was he a moody guy? What kind of a personality was this person, right?
I tried doing a little bit of research, and the only thing I could really find is some reports saying that, he would get really angry when people wouldn't understand his theories. And that kind of aligns with, being on the spectrum sometimes. Or it could.
It also depends on your audience, and his audience was the filthy rich. I hate to say
it, they probably just didn't get what he was talking about.
They didn't care.
Actually, that's right. They didn't care. All they cared about was the dollar sign that they were going to get from it.
And he was altruistic, according to what we read about him.
Yeah, maybe even a little ignorant in being so,
The only guy that I know of that really understood him was his assistant. And he had a couple of them. And what's his name? Westinghouse. He understood Tesla. They got along really well.
Yeah.
They were actually, I would say, probably good friends because they were on the same engineering level. You know what I mean?
Mm-hmm. Yeah.
Because Westinghouse, he got famous, building the brake system for trains back in those days. That's where he made his millions. So he was already, rigged up for all this equipment, coils and transformers. He had all the machinery to do the work that Tesla needed.
You know who else was good friends with Tesla? The guy who wrote Huckleberry Finn.
Really?
Yeah.
That's
what's
cool.
his name? Oh no, that's on the tip of my tongue.
Yeah, white hair, always wear white in the movies, sort of thing. But
I loved that book when I read it as a kid.
He would listen to Tesla for hours, and they would talk back and forth. And apparently, he wrote a lot of stories about Tesla, but I haven't seen any, so I don't know. But you guys know
Interesting
who
looking
wrote,
into.
Yeah, I know who you're talking about. It's that name
Mark
that's on the
Twain.
tip of my tongue. Mark
Thank
Twain.
you,
That's
Mark
it.
Twain. Yeah.
Yeah.
You know, yeah, yeah, there were stories of Mark Twain and Tesla sitting on a park bench just talking for hours.
Oh, for sure. They were good friends. Him and Mark Twain were good friends. I don't know. It was just kind of a mutual respect between the two because, Mark Twain was, I guess, a bit of an, what do you call it? Eccentric, right?
Mm.
And Tesla, in his own right, was very eccentric. So they just kind of meshed together good, right?
Yeah.
Because
And Twain was friends with Edison as well. So that like they would get together and sometimes Twain and Tesla would bicker according to, or not Twain, but Edison and Tesla would bicker according to Mark Twain. I was reading some of his notes and poetry from back in the day, and he mentions both of that. And I was like, how the heck did he know?
yeah,
But
I think
right?
things just got a little sour and between Tesla and what's his name?
Edison? Yeah, because he was
Edison. Well, I think the big architect behind that was J.P. Morgan. I think he really kind of set those two off in a real bad direction, and I think that was by design to get those guys apart. Because if he was able to get those two guys together and collaborate together, they would have been able to accomplish incredible things together. But because the way Tesla's direction he wanted to go in, JP Morgan didn't want to have that. It wasn't in his best interest.
about
right?
the money, right?
Yeah.
So basically, J.P. Morgan could be known as the most greediest hearted man ever in history because he destroyed or paused the chances of the world having wireless free energy.
I mean, most of that hinged on him. Yeah, unfortunately. Yeah. Like if we didn't have him in history, there was probably going to be a greater chance of that happening.
Yeah, down the road when they had the big meeting at Jekyll Island, that was pretty much it for North America, especially the US.
And that's the problem with, monopolization of industry. You have these giant industries and like one person is in control of that decision,
Yeah. So, there was a lot of players involved in that time. Very fascinating backgrounds.
I can't
I'm
wait
excited to hear more about it. I'm sorry, Gerald.
And we're gonna talk about your Renegade coil. That's the one we're looking at.
Yeah, the whole Renegade device, I'm going to talk about some of the geometries with it that I found very, very interesting.
Oh, cool.
It turns out the geometry of my Renegade is basically the same angle latitude of the Earth's axis. I did not know. My motor actually will activate at 23.5 degrees off its axis.
Huh. So it's like Bob Ross's Happy Little Accidents.
Well, see, I always set my trigger at 23.5 degrees, not thinking, well, is that the same degrees of the Earth's axis? And
yeah.
I didn't know that. I didn't know that for the long over 5 years. I did not know this. And then I was looking at, I was watching a video and it said, the Earth's axis is 23.5 degrees. And then it dawned on me, my Renegade. I'm like, no way. No way.
So let me bring something up to you that's 23.5 degrees as well. Okay. So this goes to what we've been working on, right? We're all working on toroids, and I'm not saying we're working on black holes or white holes or anything like that, but part of my theory goes to the fact that the energy is coming from beyond the Planck scale. Now, there's a theory out there, and it's interesting, and I only say it's interesting because the theory goes that it's a fifth dimension, and it goes beyond the Planck scale, and that's where we're pulling the energy from. But check this out. Okay, so A fifth dimension observed takes on the form of a toroid with a radius of 10 to the minus 30 centimeters, or more accurately, 23.5 times the Planck scale.
There you go. See?
So that was interesting when you said that. It was like, okay, so we're getting somewhere here, because that 23.5 is connected to my system in another way.
Right.
So awesome job, Mike.
So like my trigger closest to the coil. So basically, if you use the center axis of my the wheel, okay, line that up with the coil, and you go 23.5 degrees away from the coil. If you put your trigger there, it lets the motor run. It's exactly at the right timing area for it to trigger. Now, okay, so keeping that in mind, now there's, north, south pole, all right, and now you also have a pole on your west and east. You could also put your triggers there as well, and the motor will work in a different way.
Yep. Absolutely. That goes right along with when I put pickup coils around the outside of my big coil. Where I put those pickup coils defines the action that I'm going to do with the whole system.
Yeah, exactly. So there's a lot of stuff there. Like, I've been working on the Renegade for well over 7 years.
Nice.
So, and that's why I'm able to get a current-free potential to run that system and put out the power that it does. It's a lot of little things, but it all started with the Adams motor. That actually predates John Bedini's motor. Robert Adams. Yeah, Robert Adams had his very first motor running in 1968. So that's how
we were just talking about the other day. That's interesting. But it goes back to, we're all building off of somebody else's work.
Right.
This stuff is so old, and we just don't know how far back it goes, most of us at least.
Yeah, and the other thing too is somebody claims it's theirs when it's really somebody else's, and comes up with a new name for it and rehashes the same idea over and over and over again.
Yeah,
we're all rediscovering sort of thing, right?
Right. It's like me. Mine's a spin-off of the Adams motor. Well, I call mine the Renegade because I built it, so I call it what my version of it is.
Like, news for everyone, it goes back a lot further than that. We just don't know.
Right.
Yeah.
Right.
Yeah, like with the I'm sorry, I can never pronounce that word. Yeah, exactly. Thank you.
Got man on your brain, huh?
I'm a man eater. What?
Mandela.
It's with an O. Okay, Mandela.
Yeah. They're just man. It's got a lot of man in it.
Got some meat, Mike.
Come on, this is a family show.
Oh, not after that big coil show last week. It is not.
That kind of blew that out of the water.
Oh, no. I got something for you, Mike. You can't go anywhere until I show it to you.
Oh, are we talking the schmuck?
Oh, yeah, we're talking the schmuck. Okay, hold on.
Oh, yes.
So everybody, if you want to hear a dirty joke, a white horse fell in the mud. There you go. Okay.
All right.
Thought I'd share.
You guys ready? Here we go. I'm going to play it.
Right. Let her
So
rip.
I didn't put this on my channel. I'm just going to show it for you guys.
I laughed so hard.
Attention, crew. This is your captain speaking. Can I please have everybody assemble at the view screen? Admiral Jack would like to address everybody at once. Admiral Jack, would you like to address everybody?
All these wannabe schmucks, they have a keyboard and they can get on the internet, so they're suddenly the experts.
Did he just call us all schmucks?
Schmuck.
Schmuck.
Yeah, schmuck.
I was microdosing mushrooms that day. That day I was.
Admiral Jack, we tried to get our transporters fixed. We reached out to the physics community for help. What do you think about it?
I think they're idiots. I think that when it comes to physics, they don't know what the fuck they're talking about. And anybody who pays any attention to them, gives them any credibility, is stupider than they are. That's what I think.
Man, those people in physics sure didn't rub Jack the right way.
Given the chance, Jack will rub your grandma in the right way. Don't you worry about that.
You'll rub your grandma the right way.
Oh yeah, I agree. I
Much
totally
luck,
agree.
Aaron.
It's all bullshit. It's all bullshit, okay?
Admiral Jack, maybe you can help us out with another thing. Joe tried to cook his hot dogs in the warp drive, and he screwed up something with the mass.
And he's made some very elementary mistakes. He violates Einstein's equation equals mc squared. He doesn't know the difference between the mass and the gravitational field, that the weight of an object is W equals mg.
You all heard the Admiral. Let's get this toroid out and let's get everything fixed.
Well, just an example, the inside of the toroid, that's about 3-inch diameter, 3.5-inch diameter.
Was I right to say it's about 6 inches in diameter altogether?
Yeah, maybe a touch bigger.
Oh, it's an awfully big hole, Mike.
Don't go there.
It's Canadian. There's 3 holes.
All right, so you're gonna hook it up, and then we're gonna
Oh,
throw hot dogs through it like a carnival would.
Nothing more.
Oh my God, I'm choking here.
This is what happens when you have me on. Don't we already know this?
Yeah.
At least Gerald ain't drawing the circuit for it.
Oh my God, we sound like a bunch of schmucks.
Schmuck.
Schmuck.
You're not a schmuck.
Don't tell me about what other schmucks say. Only I'm the big schmuck here, okay?
Oh man.
Admiral Schmuck.
I'm actually honored you actually had my voiceover in there.
Oh, we had to, man. As soon as we heard the big hole theory,
That was awesome.
Excuse me. Oh my God.
We're Canadian. There's 3 holes.
Yeah.
There's too many holes there, boy.
Oh.
And if there's not enough, we make another hole.
Oh yeah, I had to do it, man. I had to.
That was great. I'm actually honored.
Well, thank you. Oh,
That was
Gotta
a
go
good
evacuate my black hole.
That was a good version of the Admiral there. That's awesome.
Yeah, that was funny.
Good.
oh man. I just like how he talks down to everybody.
I bet you Jack would even laugh at that one.
Oh man. That's so bad.
I'm assuming maybe somebody called him out on it. That's why he said, I'm the head schmuck.
Oh, everybody does. Mhm.
Oh yeah.
It's
Be a schmuck.
joke.
Hey, I'm not gonna lie. I could be a schmuck.
I got one more to show you guys, and I'm going to offend everybody, okay? But I have to do it, okay?
Oh no.
Why?
Why?
It's not you guys. I'm gonna
Just
offend
don't
other
jars.
groups and piss them off.
Yeah, don't show him that AI that I sent you.
Hold on.
So I'll do this. White shadow.
So I was making a comic strip, and sorry, I'm so sorry. I had to. The only thing Jack could say is schmuck, and then Jeremy always interviews him, so I had to have him in there as Robin, and then Bernie had to rob the bank. And
Hey,
I've got the doughboys with him.
you can use schmuck as an onomatopoeia. You know, like how they go bam or wham when they hit somebody.
Oh man. I'm sorry, guys. I'm so sorry. but I had to. It was
I'm
just
killing myself back to that's why I had to mute out, man. Wow. Get tears in my eyes. That was just hilarious.
I guess I should stop playing with that program for a while. God,
You're getting
it's
too
in
good
so
at it.
much trouble.
We have too much fun on this show.
Life is short. Gotta enjoy it.
That's right.
Oh, we
Instead
all.
of being schmucks.
You could almost, yeah, hey, Nathan, you could almost make a separate channel just for these spoofs.
Yeah.
Almost.
You
I
could,
bet
yeah.
you take off too.
Yeah, you
Oh,
probably
man.
get monetized pretty soon.
I probably would. And dude, I'm so sorry. I don't mean to piss everybody off, but it was too good to let go because his face fit perfectly on Robin when I did Jeremy. And
And Bernie as the Joker, that was hilarious.
hold on, let me show it again.
Yeah, it's perfect. Green hair and all.
I mean,
Next, you got to make me the Penguin.
There you go.
oh man, I was gonna write a story, but I just couldn't stop laughing long enough to when I see it to write the story.
Or do like even a Batman friggin' spoof.
Yeah, just do the Batman theme with it. No, schmuck man.
Schmuck man. There you go. There's a good one.
Oh, I'm gonna have to quote myself later. When I think
Or SpongeBob. SpongeBob would be another good one.
oh God, sometimes, man.
SpongeBob.
You do something with the jellyfish jam clip from SpongeBob.
Yeah, that'd be Surfati. Squidward or something like that.
Sufati Squidward. That would be perfect.
Oh, I don't mean any offense by that, guys. It's all good humor. I'm sure that they'll put my face on something. Some people already have, so I think
I'm right there with you, Nathan. I tell people, look at my channel. I make fun of myself more than anybody.
Yeah, it's great respect, you know? No worries. That's the way I don't know.
But that schmuck thing, man, I just had to do it. I'm Admiral Schmuck.
That's perfect.
That's funny. That's funny because like anybody who knows me, like especially my family, I use schmuck all the time, right? Especially when no, I do. Even way before this, I've always used schmuckaroo.
Oh, so funny. I sent Bernie the thing earlier, like a couple days ago, so hopefully he saw it before anything. He never said anything back, so
yeah.
Well, it couldn't be a bad thing then.
No,
I haven't seen much of Bernie lately.
Oh,
here and there, but
David Chester Alfred. I was thinking more of the what's that guy with the question mark?
Oh, Riddler.
Yeah. He's got the mustache that like
he does. Good idea. Yeah. Yeah.
Oh,
he would get a kick out of that. Chester's got a sense of humor.
oh man, what's that other guy he was interviewing on there? The smart guy that was usually about money.
Oh, Rossi? David Rossi? No.
I don't know. He was just doing it like a week ago. No, a couple days ago, actually. The guy has his name up in lights behind him.
Yeah, I'm surprised. I've reached out to Rossi a few times because I know he lives near me, right? And he never called me back or emailed me or anything like that. He just kind of
He says he's under an NDA, so he doesn't like making new friends. But yet, most of his stuff's behind a paywall, so I don't know.
Yeah,
I'm not. I don't know much about him.
I personally haven't seen anything that he's done. Like,
I hear about what he's done. He's working on
that's it.
Yeah, a permanent magnet motor that apparently works, and the military got interested in it, and he's got contracts with them over it. least that's the rumor. I don't know how true it is.
Yeah,
But-
yeah, it's all talk. I haven't seen anything that he has done, so why should I believe him? You know what I mean? Like, I haven't seen anything. I've shown almost everything that I've made. I've shown, right?
Me too.
So,
Almost.
I don't know. That's just me. I don't know. I'm being a little cynical.
I keep some tricks in my bag, but yeah.
Oh,
Yeah, like you.
there it is. There's the name. So I'm sorry, guys. I interrupted. Forbes.
Forbes.
Orbs.
Ashton Forbes, he's a cool guy. Yeah.
Yeah, I've
He's on the
spoken
ball.
with him. Yeah.
But at the same time, Ashton, big shout out if you're listening. Love you, man. But siding with certain individuals aren't going to get you to where you want to be. Just saying. Keep an open mind, man. That's all.
Yeah.
That being said, what were you going to say, Nathan? Sorry.
No, I'm okay. I interrupted and I had a brain fart and I had to get it out.
And then I interrupted you, which interrupted Mike prior. So,
That's
Mike,
I get a lot of farts, but it's from the wrong end.
Oh
I
man.
agree with you there.
Yeah. But yeah, things are looking good. I've been working on the cells again. I got another cell built today. So I got them running on the pulsing circuit. And yeah, they're putting out decent power. I'm pretty happy with it. I got a few other little ideas that I want to experiment with. And yeah, things are trucking along, right?
Nice.
Nice. Very cool.
Yeah, and I can miniaturize this too. I can make it, as big as your finger. I can make it, there's no limit, right? There's no limit to size.
Yeah, I'm going to show something cool on my presentation.
Oh,
Hopefully.
hold on. That's Sunday.
Oh, don't remind me, man.
No. You can't back out. You said
You know how nervous I am.
I'm nervous.
Oh, please.
I don't know if I got all my theory right, but it's the first edition. I'm hammering it out. And it's not even like I'm not submitting it to a university or a paper or anything. I'm basically just putting it out there for the audience to understand what I'm doing.
No, there you go.
Yeah, and it might trigger somebody who's working on something similar, give them an idea to send them in the right direction.
That's right.
Absolutely. Although the next coil, I don't know if anyone's going to be able to build it. It was tough for even me, man. The precursor to that, to the sphere that I was talking about on the last live, I put a video out today of it's like a test coil for the sphere. I wanted to see if I was right when it came to compressing the fields in a certain way.
Mm-hmm.
Totally right. The cavity that we talked about, right? Cashmere cavity. So this coil compresses on the bottom, and then it's got a cavity that comes around like this, and then it compresses on the top. And there's a hole in the bottom and a hole in the top. Now, I was going to put two cones in the center, but this one, when I wired it, compressed so tight, I just decided to use it for a test rig, right? I'm getting crazy amounts out of it. Like I'm now lighting that LED bank, filling up a capacitor to 175 volts, and I'm charging a 12-volt battery that's 22 amp hour off of a 12-volt battery that's 12 amp hour, and I'm only using 0.05 of a volt. So I'm going to put that on a proper meter to get the actual reading. I think it's something like 50 millivolts or something like that. It's crazy low, like stupid low. And I got all this running now. It's all about the compression of the fields, the capacitance of the coil system. Or in Mike's case, the capacitance of his coil system around his running motor that runs basically on a fart. Sorry, Mike. Your motor runs so efficiently, it's like that. With that expression.
Yeah, it runs on stink.
I never said it stunk. I just said it ran out of fart. You burp in that direction, the thing's gonna start spinning, man. You got that
Yep.
sucker too nice.
That's right. That's the whole idea.
Yeah, absolutely.
The turtle will win. Well, it just boils down to the turtle will win the race. Right?
Yep.
You don't have to be the rabbit.
Yep. I'm at 180 now, and I still have 20 more coils planned. When I hit 200, I'm going to stop and finish the devices that I designed that go along with about 10 of those coils. And then who knows? We'll see what happens from there. Everybody has to, I think, a seminar maybe for everyone or a get together, and then bring a whole bunch of test equipment, and everybody could test it live right there and play with it and this, that, and the other, right? And prove me wrong or prove me right, whatever. I'm open to both. So that's the idea. That's what I would love to do. And I can get the space for everybody to come, right? So something to think about in the near future. Anyway, did I cut somebody off again? You and my big mouth?
Nope, not at all. I'm just doing a dissection of my cells that have been running since August. So I'm checking to see if my special agent is protecting the magnesium.
Hey, I got a question, Nathan, from one of the viewers. Peter is asking, what is a good 3D print program that I can start from scratch and make a 0% custom part? I'm not sure what 0% means, but
I use Fusion 360.
Fusion 360.
Yeah. It's a little bit harder to start with, but the payoff is so much bigger than the other programs. The other ones hit a finite limitation, and this one doesn't.
Okay, so you'll probably, using the other ones you're saying, you'll probably reach a limit that you're going to need to cross anyway, so just go with Fusion. Yeah,
and I'll be honest with you, man, once you get used to the quick keys and stuff, I can probably build a part in like 20 minutes, just out of my head, and just using my little, millimeter ruler, and, you get the size real quick, and you can figure it out. So I don't ever use the sketch on it. I only go straight to putting the part, the sizes and everything in, and it'll make 3D parts in no time.
Is it a pay for program or is it freeware?
It's free.
Oh, nice.
Yep, you can register as a hobbyist, and they'll give it to you for 5 years, and then after that, you just re-register again, and you're good to go.
Oh, that's awesome. That's good for me too, because I'm going to be getting into that territory soon.
Yeah, you need a decent computer with a decent amount of RAM in it. I recommend at least 8 gig of RAM in your system, and half terabyte hard drive's good enough. Yep, CPU. Just make sure you have a modern CPU. An i5 or i7 or whatever.
I got a Ryzen, so I'm good.
Yeah.
I love them things. When I built this computer, I was so satisfied with how smoothly everything ran on the Ryzen.
But by the way, Gerald, I will need your address here pretty soon. You're getting a printer in the mail. Ben, you're getting one too. So they're already packed up in the box. They weigh about 50 pounds. So shipping's like through the roof, but you're getting them.
Wow. Oh, wow. Thank you, Nathan.
I pay for it.
No, don't worry about it. I got it.
Yeah, you had to.
We'll talk off there.
Yeah, we'll figure something else out.
So
we're good.
This is my new straw, right?
Oh, what's this?
Yeah, you were showing that earlier.
This is quartz. This is
it's quartz?
Yeah.
Oh, so that can act as a resonance chamber.
Maybe.
Yeah, nice.
Maybe. Oh, Gerald's onto something. Just cooking up something.
Something's coming from this in the near future. I've been building coils for a purpose, and this is one of them.
Nice. So he's got like this end goal that we can't see yet, and he's going to. It's like a finale. It's the finale of the season of Gerald.
There you go.
I love it. I can't wait.
Hopefully I'll
No,
get there.
everything's coming together. We got Mike from Faraday Research, and his stuff's coming together, and we have
He's our
Phil. And
battery guy.
Mhm.
He's our battery guy. You're our rodent guy. No. And then we got Nathan.
We got the schmuck.
Like,
King of the schmuck.
And then we have our resident schmuck.
Admiral Schmuck.
Admiral Schmuck. That was hilarious.
Corporal Schmuck.
Corporal Schmuck.
I love
So
it.
funny.
Senior Schmuck.
Jack's hilarious.
Oh, you know what? The funny thing is, he has nuggets of wisdom in there, and I don't know that anybody picked up on them. But when I cut through all of the noise, and I love to do this with people's stuff. I'll download the actual video, right?
Yeah.
And I'll start cutting it, and then I'll delete, the garbage and the background and all the hee-haw and everybody else talking, and I get down to what the person actually says, and then I'll check it for facts. So I look to see which facts he's letting out and why. And, he lets little pearls and nuggets out there once in a while. Yeah. And,
You think it's intentional, or you think it's like a Freudian slip?
No. It's like a Freudian slip. It's like,
Yeah.
I don't know. Yeah. Because he's like, no, you schmucks, you're not getting it right. Schmucks, this is the way it goes. This is what I'm telling you, and this is how it works. Okay?
Mhm.
And he's like telling you to shut up to your face, and he's being nice by calling you a schmuck.
Yeah, he's an old school teacher. So when you poke his buttons, he wants to teach you with a slap in the head. So
Yeah, that's exactly. Yeah, that's a good way of putting it.
So here's what he told you. Okay? Everybody says high frequency, high energy, right? He tells you, no, it's low frequency and the energy isn't harmful. Okay? Flat out. And I'm sorry, that was a big deal. And they just, ha. Yeah, well, you're schmutty. No. Listen to the man when he talks, cut out the rest of the garbage, and you'll find the pearls. So, no, he's got it. And he knows when he sees it, because if he can identify that point, that is something that's not well known anywhere. Okay? Aside from what we're talking about, nobody really talks about that at all. They don't even understand it. They still talk about how much energy it takes to lift something and how much fuel and size and weight and all this garbage, okay, that just right out the door as soon as Jack says that. He's like, no, you guys are idiots.
Yeah. And they don't pick up on it at all.
No, none of them do.
No. And if you're playing with this stuff and you don't understand how to get this energy to come out, you could hurt yourself, right?
Oh, you
I mean,
could.
I've been doing it since 2008, and if I was doing it wrong, I wouldn't be doing it anymore because I wouldn't be here.
Yeah, but if you flip cold energy into hot energy too fast and you grab it like you did that coil that day, you're going to get frozen and going to have the shivers, and it may cause other things, you don't want to do. So there is a danger to it.
There is. I'm not saying it's perfectly safe, but I know things I'm not supposed to do. And the things I do, I think are okay. Or I wouldn't, like I said, I mean, since 2008, right? So.
Right. And the only reason I'm comfortable around the rodent coil is because I know there's been years of research around it already, and I know the precautions to take. But when working on your coil, I definitely going to need a lot more, ventilation, a lot safer of a setup, gas detectors.
Mike's advice and be a wuss and only use 12 volts.
Yeah, that's true.
By the way, Gerald, we
Yeah,
talked about the inverse. Directly correlates to what he said.
I know. Jack's got it. Like, he understands what's going on.
I
But
didn't
he
think
can't
he
really
understood it until I cut it apart.
I believe he does. I believe he has for a long time, but he's been keeping it secret because either he was read in or He worked in those programs. He definitely worked with the people that were in those programs.
Mhm.
So I don't know what to say. I make fun of Jack because he's a bit of a dick, but other than that, he's a very smart man. Oh, hey, I'm willing to call a spade a spade. I can be an asshole, pardon my language, but you know, you know that song by Dennis Leary, I'm an a-hole. My family plays that. Okay, so and I'm not a mean guy at all, but it's like a long-standing joke. So yeah, he calls himself a schmuck. Well, I call myself another thing. So here you go. Anyway.
Hey Nathan, what do you think about a new series? Is it a coil or cake?
I don't know.
Come on, guys, you gotta tell. Is it a coil or is it cake?
I hope it's not a pie.
Guys, I gotta step away for about 10 minutes. I'll pop back in.
Okay.
Oh, you're not playing the flute.
We're timing it.
No.
Oh,
Well, thanks for
Don't
stopping
give me
by,
the
Mike.
idea.
We'll see you in a little bit.
No.
I might.
Yeah, I'll come back. Okay.
Okay. Oh, that's so bad, guys. You guys are bad. I thought I was the only one.
Yeah,
I'm not.
we're horrible. I'm sorry.
Oh,
I'll be right back.
oh, everybody's being right back. Oh man, that's so.
Everybody's
funny.
funny. Now you funny too.
Oh my god, the funniest part of that video, by the way, when I did it, it was you, Ben. It was so funny because Bernie started talking about your mama, and you go, "Yep, that's right." It's all from the same clip too. Oh man, no, but I thought that was interesting because I did that to a couple of Jack's interviews, and absolutely, there's some truth in there. And it's when he talks about the different energy types, and you're not listening, is when he gets you, and he can identify them right away. That's what I find funny because he directly addressed it, and that total different level of understanding of who that guy was as soon as I heard that. And,
I should go over some of his footage and analyze his footage for micro expressions.
Well, I don't know about all that. I just know sometimes people say stuff and they don't realize they're saying it, and you have to find those times, especially when it comes to smart people. Like, you know how many times I clipped the part Bedini just to figure it out, and then throw all the junk away and all the other people in the room talking just so I can hear exactly what was going on. So I do that a lot, man, and I cannot stand all the other little stuff in there while I'm doing that because I could barely hear when people start talking over other people. It's just a mess. So anyway. All right. By the way, Shawn, you were asking what was going on earlier. I showed the circuits earlier for adding PWM to your voltage and stuff like that to run flybacks and to run other things like that. PWM, also duty cycle. So anybody who runs a coil system, it would absolutely help them out. On the DC side of things and the frequency that you put into them, things like that. Because, it tells you the duration of the duty cycle. So, based on the percentage that you put in, so how much time it's actually going to run for and actually how much time it's going to stop. So it makes things so much faster, so much easier to understand. And the cool thing is when you do it with the high voltage, you can see the immediate impact of it and it's going to work in your system.
You mean that little circuit, that little PWM?
Yeah.
You made sorry, go ahead.
No, I was just going to say, when I hooked it up to my flybacks, that they don't like to lie to you when it comes to high voltage. It tells you exactly where it's going to go and what it's going to do. It immediately does it so that when you put it in a lower pulse circuit, that you're getting the right effect.
I'll have to go back and watch where you put that resistor. What was it, a 2K you said?
No Ks. just a 20 ohm.
Oh, a 20 ohm. Okay.
Yeah.
Okay.
Any higher, and it'll stop the pulse wave from going through it. You'll have too much resistance because remember you're only putting in like 12 volts in the primary of that little circuit.
That's
so
true.
yeah, you're gonna kill it with enough. You could probably go through it, but it's gonna dilute the signal so much it's not worth it. So I'll tell you another way to do it. Okay. And when you have the worst wires in the world, it works. Okay. All you have to do is put the signal in with the other wires. So if I literally took my wires that went on to my high voltage and I wrapped a wire around them and put a PWM in it,
Yeah.
guess what? It carries that wave.
That's cool.
It only works with very, very bad wires. So if they're well insulated, forget it, it won't work. But when they're not, oh, then the fun begins.
Yeah, because you get the bleed, eh? You get the bleed off.
That's right.
Yeah.
It really goes down to the energy travels on the outside of the wire, not the inside of the wire. And for that reason, it'll pick up the PWM just fine.
Yep. My coils are based on that.
Yeah. Oh, by the way, we were talking about hold on. I had a thought, just a thought. Okay, it's not a fact. So
okay, throw it out there.
The crystals on the plate for the Ark of the Covenant. Okay.
Mm-hmm.
We could never find them to get color in them to light up. And I think I figured out why. Okay. We know that frequency activates quartz. We know that one side of quartz is magnetic.
Yeah.
Now I want you to think about your coil and tell me what systems are missing.
Scalar. So plus your heat, your cold, is that what you're talking about?
Each side of the piece of quartz is reactive to one thing. So if I put your coil here, right?
Yeah.
And I told you I got frequency.
Yeah.
Now I got energy, okay, which controls my magnetism, which then controls my sound, which then you get what I'm getting at? Okay. Every single effect. Now, when you build this thing, you have to get all those effects in line in order to activate the quartz correctly because each side of the quartz is different on every single thing it's picking up. So one side we know is magnetic. We know the other side works on frequency. So as soon as you add in the others, we should finally be able to activate it the correct way and get it to light up. That's just my thought.
Wait a second. So what you're saying is you figure that my coil will activate the Ark of the Covenant?
It should be what's inside of it, but not the amount of layers you have. I think there's like 9 to 12 layers in there. And because some things are in resonance and some things are not.
Me and you got to discuss that exact subject offline. It goes to a dream I had. You just blew my mind. And I have it written down and dated. I'm telling you.
But it makes sense, right? And then
it does.
Because there's more to it. It can't just be what they say and put it in a radio and just tap it back. It can't just be putting your magnet to it and getting that one side that's magnetic when the rest of them aren't. Okay. You're activating oxygen in there. We knew it was magnetic in some way. You know what I mean? There's a crystalline form. Therefore, we know that it creates a shape originally, okay, which would mimic the wire that you're putting in your coil. Now you just have to hit the other layers to turn it on properly. It could be a whole different thing in there, right? But there's no way that that plate lights up those colors of different quartz and things like that would be on that plate, rubies or whatever there's on there, without something of that type.
Yeah. You know what? That's That's absolutely amazing and correct. And I could actually elaborate. If you think of the robes that those priests wore with that plate and all those stones, they had to walk around the inside of the temple a very specific way. And if they walked outside that line, they'd fry.
Wow.
And I think the reason why was because they were walking the line, which would be like the wire, and they were grounding themselves out because their plate was a certain frequency. That was the signal to be able to get close to the Ark of the Covenant in order to shut it off so they could do their work in there. And when they left, they had to leave a very specific way. Makes me wonder if they hit it with an ankh or something, made it ring, turned the Ark back on, and walked away. Because the Ark's like a communication device as well. There's a lot more to it than just a capacitor.
Well,
Yeah, those chest plates, they weren't ceremonial. They actually served a purpose, right? They were for insulation.
They were very specific. They had 12 different stones in it, precious stones, and each one has a frequency. And that gold plate was like an inch thick. And you'd wear it over your chest, right? And it was strapped in a certain way, and you'd wear a certain type of robe. And
it was like a portable Faraday cage or something.
So I don't know. It's
well, when you get into the time dilation feature of what's going on, it's going to make a lot more sense. Now, if you are in a time dilation field, okay, it's the field that passes from the coil to you and through you. Then when it comes back to you and through you, okay, if you were separated from that event, you may not feel that what happens there at all.
Oh, I see what you mean.
So if you gotten, say, a barrel that was like a Faraday cage or a better version of it, and you were there, you may not feel those effects that happen at all. But since it has to build out, you're going to be in the way. Since it has to go back, you're going to be in the way. So if you were looking for something in one direction, you would allow that to happen, jump in the barrel so that when it goes back in the other direction, those effects stay permanent. So it's an interesting idea and concept to throw on top of all of the stuff that we do, but
yeah,
it would make it understandable, because if we are energy and all time is a factor of energy, then it makes sense that time happens at all time, all the time, and it just has to do with the frequency in order to change that time to be in the right place at the right time. Now, if you can get how convoluted that is and understand it, then it might make sense to you. Okay? Yeah. If you can really understand frequency equals 1 over time, I just explained it with saying time 100 times.
Now, that's not including the mechanism to get into that very specific situation.
Nope.
But yeah, you're absolutely right.
It just
makes one wonder.
Yeah, you go backwards, you go forwards. We'll meet some dinosaurs, and then we'll meet some space aliens in the future. And
I had a dream about the Ark of the Covenant, and in between the two angels' wings that are pointed forward, when this thing was activated and it was floating and the priests were, they say we're carrying it. I don't believe so. From my understanding, the Ark of the Covenant would levitate and follow the ley lines. And in between those two wings was a sphere, an Evo of ball lightning.
Oh, that'd be cool. Yeah.
How God communicated with the people that were holding the Ark of the Covenant. From my understanding, I could be wrong, but from my research, that's what it points to. Right? So, anyway, I'll get off. That, well, it's just amazing. Go ahead.
It also tells you why frequency would make everybody sick, and it's not due to atoms. Okay, doing the splitting of the atoms for like nuclear, but it is frequency because right now the U.S. military has devices they can put out frequency to make you sick, make you think you're boiling in water.
And
all these
everybody
things.
thinks it's magic, but what do you think it's the frequency of? It's the frequency of the molecules of the water within your body that they're affecting.
That's right.
Yeah.
Are literally evaporating the molecules in your body.
No, because that would kill you. What they're doing is they're vibrating them at a
they're
certain
oscillating
frequency.
it. Oh, so they're not destroying it, they're just oscillating, they're messing it up. Okay.
Which messes with your body's natural
equilibrium.
System. Yeah. They affect it through the endocrine system, right? So if you were like, there's a couple specific frequencies that are apparently really nasty. Like one makes you shit yourself. Pardon me.
Yeah, it's the brown node.
I've never tried it. I don't want to play with anything like that. But
you could say it was the brown node.
Yeah,
the brown node, that's what it's called. The brown node. It's a well-known thing, and apparently they point this, I don't know, device at you, and they pull the trigger, and you instantly lose it.
Oh
man.
Yeah, that guy gets it. He's wearing the brown pants.
Yeah.
So no one can see me.
That's it. So I mean, I don't know. This stuff's crazy, right?
Oh,
but
wow.
that's not the goal. The goal is entirely different.
Oh,
you know.
Oh, it's so funny, man.
The frequency's important.
What did Mike say? Mike said something funny up here.
You're imparting energy into your body. Well, what are you imparting the energy into? Water.
Mike says, yeah, I love time dilation fields. When I pass gas, time stops.
Oh, that'd be horrible.
When you pass gas, life stops. Kidding, Mike. I love it. That's awesome. You're great, bud. You're great.
Like 20 cheeseburgers from McDonald's? Yeah, because you wouldn't go broke then.
You know what? I'm not allowed. My whole family, I'm not allowed to eat pistachios. If we go visit somewhere and there's pistachios, this is funny. Went to my buddy's place and had a dinner first. The whole family's there. There's a bowl of pistachios on the table, and I go to grab from my whole family. No, because if I eat 2, 3, I will gas the whole house out, man. Oh. One of those things.
Hey, when we have to prep for warfare, we're gonna grab you and a bowl of pistachios.
You know it, man. But you'll be the gas masks.
I can see it now. They pull out the portable shower, right? And there's a guy washing. Gerald goes, "It's just the pistachios." And he just looks at you and goes, "You should really be ashamed of yourself, sir."
Yeah.
Oh man.
Awesome.
Oh, it's so great.
Can't eat pistachios. Pistachios ice cream is worse.
Oh yeah, that's got to be a bad combination right there.
I love the flavor. I can sit there and eat half a bucket, right? But man, do the people around me pay for it? It's bad.
Wow.
I wish you guys could see this box of cuteness.
Oh, you got kitties over there?
You know what? That box where I had the quartz tubes, I pulled it out and I put it on the ground. They all jumped on it. So I'm gonna see if I can show you there.
Oh.
So they're all sleeping, cuddled together, all piled on that little box. So I just thought that was cute. You guys had to see that.
Yeah, that's adorable.
Yeah, my cats, any blanket you put out, any box, they always jump in. Yeah, everything.
What is it with cats and boxes? I don't know. It's weird.
I don't know. I have this little tunnel thing. It's like, about 2 feet long.
Yeah.
And they love getting in there and they hide, wait for the other one to run by, and they pull them right out and get them.
We have an indoor air conditioner, and it's got this plastic tube that extends really long. So in the wintertime, I just pull it off and I put it in the corner, and my adult cats will climb through it once in a while. These kittens love it, man. They get inside and they're playing in it, around it, and it's just crazy. They love tubes and boxes. Go figure.
Oh, by the way, that tube you had,
Yeah.
If you had another one just smaller than that,
Yeah.
you could take a tuning fork, strike it, put it on the top of the smaller tube, move it up and down, and you'll find the resonance frequency.
Right.
Wait, say that again? You can put a tuning fork on top of the what? The
Hey, hold on. Take a crystal tube, like
Uh-huh.
Gerald showed. Take a one that has a little bit smaller of a diameter. Then take a tuning fork and strike it. Put it above the smaller one and raise and lower the smaller one inside the bigger one, and it'll actually hit the right frequency of the crystal in there, and you'll have resonance.
Yeah.
Huh.
Absolutely. I got 2 of those exact ones. I don't have any smaller. Maybe I'll order another
Right,
set.
because the tuning fork is in what? Usually in C, middle C.
Depends on the fork.
Depends on the fork. Because
Yeah.
I
And you
know,
gotta-
but sliding the tubes in on one another, that would be able to tune it to a different, right? A different note. Is that the idea?
Well, you hear it, right? Like it'll get louder when you get to it close to its resonant frequency as it's vibrating between the two.
Okay,
And
yeah,
you'll
I'm just picturing, like the slide from like a trumpet,
Yeah, something like that. It's more like I don't have a reference for that. It's tube in a tube, right?
Yeah.
Yeah.
Maybe not a perfect analogy, but that's just what came to mind.
Well, you have to try to do different tuning forks as well, because you may not be out in the right frequency at all with the tubes you're working with.
Right.
Yeah.
So,
well, one of those tubes is part of a electric furnace that I'm building. So for heat. So I built a whole bunch of small heaters. I'm building something bigger now. My coil's gonna run it. We'll see.
Electric kitty coil.
Yeah. If I can heat a whole basement with a couple of quartz tubes and some nichrome and a system that without moving parts, well, yippee-ki-yay, that's something everybody needs. Especially in cold areas, right?
Yeah.
Yeah. That's a go.
It's a me, Mario.
oh man.
Yeah, I don't think I'm gonna stay on super long tonight because I got a few things that I have to still do. I'm fixing my shower up on the 3rd floor and stuff like that. Obladi oblada,
Yeah, I want to talk afterwards, so let me know when it's a good time, and what I mean?
Absolutely.
So
Cut out at maybe the 2-hour mark tonight.
yeah, that'll work.
Sounds good. What else do I have on the go? I put up a couple of videos today. One of them of the just the beginning, the first stage of my 1/4-inch copper tube with the coil wrapped inside. Yeah. You know what would have helped?
What's
I
that?
should have got you to print me brackets to keep that copper tube from squeezing together. I got some awesome winding done before I had the brain fart and realized, wait a second, how come my wire's not tight anymore? I realized I was squishing it together. What's that?
I was just talking to Shawn about this problem. The cables for your distributor cables?
Yeah.
They get connected together with cheap little connectors.
Yeah.
They're about a 1/4 inch. So glue some of those, just glue them to the side and clip them, and they'll keep it right in line depending on the height you put them at. But that's the cheapest way to do it, or take blocks of wood and drill holes in the side and then route it through there so it stays the whole time.
Well, it's funny you say that because I took pine with my jigsaw and I drew it out, and then I sat there and cut it painstakingly out and popped them in. And so you do what you got to do, right? I guess with a printer, that's where a printer would come in handy. Like, I see why you guys, the appeal's there, right?
Well, there's the feature on the printer. You could put a coil over the cylinder, and it'll actually make grooves in there. So as it prints, it'll print grooves in there. That's what I'm going to use for my Tesla coils to keep the thing actually in the right spot. It'll make a C shape in there, so that it'll sit right in there and it won't come out. It can't go anywhere, and you'll be able to clip to it very easily.
Yeah, honestly, up until you made me aware how cheap the 3D printers are, I didn't look into them because I just always assumed they were going to be too expensive for my budget.
Oh, you're getting one now. So, and by the way, just so you know, on this, guys, Shawn threw in on the shipping. So,
Oh wow!
yeah, just so you
that's
know,
awesome.
guys,
Thanks,
make sure
Shawn.
you guys say thank you to Shawn.
Thank you.
Shawn's an
everybody.
awesome person.
Hats off from a balding man.
Yeah. If I had a hat, I'd take it off too. Thanks, Shawn and Nathan. We really appreciate that.
Yeah, big
Yeah,
time.
Throwing a roll of PLA for you guys to get started with, and then the little SD card, stuff like that, and
Wow.
you know, a little extra so that you guys can just be started, and then you'll just have to learn some programming.
Mm-hmm.
I don't know what to say. Thank you. Thank
Yeah.
you, Shawn. That's
Thanks.
awesome. You guys are awesome.
It is awesome.
It's good.
Honestly, it is. It leaves you speechless almost, the generosity. So
Absolutely. And it's good because I'll have your return address and I can send you the lab coats. Now, I don't know if
nice.
it's cheaper to send all the lab coats to you for Ben and Mike. I'll send him his because he's in Canada. But Mike,
if they're in the States, send them to me, and then you send everybody else in Canada.
Yeah, and then I'll just whatever shipping it costs, I'll pay you. Like we'll work it out, kind of thing, right?
Yeah.
Okay. Awesome. That's what we'll do. Can't wait to get me lab kit.
I know it's gonna be some. We're gonna look like an actual team, you know. We'll look like an actual team.
Shawn says, "Much love, guys, and make sure you get his lab coat size right."
Absolutely, I'll have to know that for sure, Shawn.
Thanks, Shawn. Many blessings.
I'm gonna put something special on the inside for you, Shawn. I'm not gonna tell you what it is.
Yeah, you're right, Ben. We got a pretty special group here, man. So
we do. Yeah, everybody is really and not just generous, but kind-hearted. You guys are not ill-intended like some of these other YouTubers that I see, and it's refreshing, honestly, because I get frustrated. You know, like why can't people just be in it for providing a service? Why do they have to be driven by other, you know, selfish needs? And you know, I'm not saying like I don't have negative qualities too, but I am aware that I need to, you know, be a better person, you know, and that's being a part of this team has made me a better person. So I hope you guys realize that, you know.
Oh, thanks, man. But don't kid yourself. I have alternative means too. Like I do want to build a business, but I want to build a business selling the devices to people that don't have time to build them or just don't want to. Everyone else, take the tech and build it yourself.
And that to me, even if it isn't registered as a nonprofit, it would be focused more on providing a service, you know, and that's what I want to do with my business, you know, provide a service and focus on that. And, you know, if I could help somebody, that's a, you know, really my ultimate goal.
Yeah, that's the way to do it, I think.
I'll be honest with you guys. I've grown accustomed to retirement. So while you guys are building a business at your age, man, I'm done. I feel you, Nathan. In my early 30s, dude. I do not want to go back to work for anybody or anything. I will sit around the campfire and have a beer with you.
Hey, I don't blame you. I don't blame you.
Yeah, I don't blame you either. Not at all. For me, though, it'll be a small business out of my house. It's not going to be anything too major, you know, just a little of this, a little of that. Maybe some consultation for people that don't quite get it, but still really want to, you know, I don't know.
Keeping your hands busy doing the good work. That's what I say, you know.
I'll do that stuff for free, bro.
Yeah.
Hey, if I had the means to, I would. You know what I mean? If I had the means to do some of this stuff for free, I definitely would.
Oh, absolutely. Go ahead. Sorry, Nate.
Just so you know, I'm cheap, so you have to bring your own beer.
BYOB.
I'll bring steaks and beer.
There you go.
If I could get out there, that is, right?
Oh my God, dude, I can cook a mean steak. It falls apart in your mouth, everything.
If you get out here, I'll go talk to the butcher that I know, and I'll go get a blade steak that's like this, and yeah, we'll have some good eaten. Either that or I'll get a bunch of tomahawk steaks. You know what a tomahawk steak is?
Yeah.
Yeah.
With a big handle.
Go. Yeah. Well, we should do that. You guys come out. We'll do tomahawks and beer.
Yeah, we'll smoke some briskets, maybe some ribs. Yeah, I know how to do that. Just takes all day. But yeah.
That's okay. What else are we doing? We'll be playing with coils and barbecue and brisket.
Maybe even barbecuing them with the coils. Who knows?
As long as we're not barbecuing ourselves, we're okay.
Why does my hamburger have a circular grill pattern?
It's art.
It's art.
Somebody brought a lot of beer.
Like the Nathan's like, did you put charcoal in my bun to make it black? No, I just burnt it.
Bun is black.
Oh man. Yeah, I mess with turkeys too, so I was doing it for my family. They tripped out. I was telling Mike Faraday, you cut this thing apart when it's raw. You take off all the skin to it, except for on the legs and the wings.
Yeah.
You put all the dark meat and the wings in one thing, and you put all the seasoning on top of it, okay? Then you take all the white meat and put it separate. Now you can put in the dark meat 15 minutes longer. And also, when you're done with that and you want to tear all the meat off of the dark side, you tear it all off, but you put it in the drippings of the pan. You never throw out the dripping. That's where all the good flavor is. That's all your seasoning. That's all your fat in there from the dark meat. So you put all the meat in there and you turn it up and get it all in there, because when it first comes out and it's hot, it still wants to suck things back into it. So it sucks all that flavor back into it. So anytime you eat it when it's cold, it's perfect. You never have to warm it up because the flavor is always there.
You're not wrong. That's a different way of cooking it. Me, I'll take the turkey. I'll go breast down. I'll go 3/4. Come on, brain. Ginger ale, and then water, and then I'll put in my onions and my potatoes, and they'll dissolve in that. Right, basically, you still get some onions in there, but the potatoes turn to like nothing, which is great because it makes for a thick gravy in the end. But with that pressed down, and every time when you go and you cut your turkey open, it's sweet, and you get the flavor of that turkey.
Well,
it's just crazy.
Nice.
All I have to say is if you spent half as amount of effort that you do on your coils on your food, I'm definitely coming over.
I love to cook, but I'm no pro. I just love to cook.
Hey, I am down for anything. So
there you go.
I don't think you understood the comment correctly. That's just sorry.
Go ahead.
I'm just so sorry.
Hey, sometimes I don't get sarcasm, so you gotta watch me, okay?
That's okay. It went like this for me.
Oh my god, that's so bad. I should.
Gerald's Italian genetics. Gerald, you're Italian too. I'm Italian.
No.
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 I'm the only Italian guy here.
I know lots of Italians. You know what I'm saying? They kind of grew up with people like this, you know. But no, I'm not Italian. I'm actually French. Don't speak a freaking word of it.
Oh, I'd love to go to Quebec though, because I used to take French class. I didn't. Oh, really? Well, I like the French culture, so maybe Paris might be a better option. But at the end of the day, like, I like the French cuisine. You know
what? I love the French cuisine, and they say that the French make the best lovers. Don't know about that. But when it comes to going to Quebec, if you don't speak Quebec French, you don't want to go to that place.
So learn the language. Is it a specific kind of French? It's a different kind of French than traditional French?
There's twang in it.
Yeah, there's twang in it, and they're very prejudiced.
Slang, yeah. Mexico's the same way. You don't go there learn Spanish and then go to Mexico. It doesn't work.
Yeah. You get treated like you're alien or something.
Paris might be a better option then.
Yeah, you probably have, especially if you could speak French from where you are now, and then you go to Paris. Well, yeah, because they don't care. You're trying. That's all that matters out there.
All right,
Yeah, it
guys,
took
I
a
got
couple
something to
years.
show you. Go ahead, Ben.
Oh no, I was just gonna say it took a couple of years, so it wouldn't be that hard to relearn some of it.
There you go.
So check this out. Charlie built this coil just like mine, and then Shawn sent them the ZVS, the new ZVS board he's working on.
Yeah.
And it actually came out really good. So I want to show you guys this.
Charlie C.
Charlie C.
Big shout out, Charlie C.
Charlie C's awesome, man.
Yeah, he is. He's always been straight up with me. I've never had an issue with Charlie C.
Oh, and he's got a lab coat. Nice.
Oh yeah, man. Right from the start, Charlie C's all about his lab coat. That's
Right.
awesome.
And what is that red thing he's twisting?
It's a Variac.
Yeah.
A Variat. What does that do? Provide the power?
It's
Yeah,
an
look at
AC voltage transformer that goes from like 0 to 120.
Oh.
Yeah, look at that voltage, man.
That's
Wow.
beautiful.
Yeah, it's cool.
That almost looks like Shawn's on his spear. Almost.
Yeah, mine does the same thing. Like,
Yeah, yours too. That's the one you put against the ruler, right?
yeah, he's got, hold on. I'm sorry. Let me pause it. It's so loud in my ears.
Wow, it's big. Look at those arcs.
He's got the color like Shawn and the tendrils like Shawn's because of the ZVS he's working with. Sorry. But mine were white, so they weren't like that, but they were just as high.
And he's learning based off of you and Shawn's work?
Shawn told him to build it in 32 gauge magnet wire at 11.5 inches on a 4-inch pipe. And yeah.
That's
Nice.
awesome.
he
That
did
means
the-
our message is starting to get out a little bit. I'm sorry.
Yeah. Charlie connected with Shawn early and talked back and forth with him on this, and it was just so awesome. And then he actually uses the LCR meter for his number 1 coil. So what's so cool about this is you take the LCR meter, you connect it to your number 1 coil, and it'll tell you the capacitance of your number 1 coil. Now you can take the capacitor and adjust the capacitor to what you want it to resonate perfectly in your circuit so that you do not have to move a wire clip anywhere on this. You notice there is no wire clip. There's nothing connecting it anywhere else. It's a simple, straightforward process. It'll stop you from pulling your hair out, and it'll actually just write what you want the first time. And it's like $120 for the meter, 100% worth it. I would have paid that to not go through the anger of 2 days and frustration of moving that clip. So
I'm not exactly sure how to find the. Okay, so I have an LCR meter, and I can find the capacitance of my primary. But what do I do with it from that point? Because I'm used to finding resonance in other ways, right? But I mean, I don't know how to deal with. Like, I found the capacitance and I found the ohms, and I looked at it all and I went, okay, so now what do I do with this? Am I supposed to add capacitance to it, or am I?
there's a math formula. I will get you the program that Shawn showed me.
Okay.
He just simply types it in.
Yeah.
And then it'll tell him exactly what he needs to know. The exact
that's beautiful.
capacitance. And then that way there's no gimmicks or messing around with it.
No
It's
guessing.
real simple. And he was showing it to me the other day, and let me just tell you something right now. You ever felt stupid and sat there for like a few minutes realizing how stupid you've been for a while to do it the old school way?
Multiple
And-
I have.
And you
Yeah,
just
you're
realize,
back.
because I was so excited to get my first one running, right? And he kept telling me about it, and I kept putting it in the back of my head, and I kept going back to the old school method, and then I go, all right, you know what? Now I feel really dumb.
Hey, sometimes you have to make those mistakes in order to learn, though. You know what I mean?
Yeah, you know what? Like Shawn put step 1. Knowing you made a mistake, that is step 1, right? Because that's how
Yeah.
you change it. So
Right. Yeah,
I'm
it's
right
like
there with you, Nathan. I don't know how to do that. So Yeah, I don't know, man.
Well, Shawn was off this week, so when he comes back in the next week or so, if he feels up to it, I'm going to have him demonstrate that in the computer program. Now, he did it last week when he did his coil. So if you want to reference back to that, we can look at that.
Yeah,
But
I missed that part. I don't know if I wasn't watching or something because I watched the video.
yeah,
Yeah.
it was so fast. No, because it's only like a minute worth of time that he spent on it. But it's how do I say this? You brush over it because there's not much there to learn, but it's so much information that you needed right at that 1 minute.
Yeah, I get that.
Oh, Gerald, I don't know if you saw it, but Mike wanted me to send you a video to check out, and I put it in the private chat.
I watched that video. It was a good video, Mike.
I haven't seen it. I'll check it out after.
Yeah, but this.
Go ahead.
Sorry, this was Charlie C and his coil. And like I said, it looks just like my gold coil.
Yeah.
Same exact size, same exact everything.
He's got the fan there. Is that to cool down the circuit right there? Is that why he has that there?
Yes.
Yeah.
Shawn said it needs it.
Yeah,
it needs a gentle breeze on it.
Well, good job, Charlie C.
Yeah, this is cool. This is awesome. And I'm glad that, you guys are inspiring other people to do some of the experiments,
Well, that's what the scientific community should have been doing right off the hop. Not, you need a PhD to be able to research this kind of stuff. Otherwise, you know what? You're a schmuck.
Yeah, you're discouraging people, especially younger generations who, like myself, I didn't think I was ever going to be smart enough to learn this stuff. So I didn't really look into it as a younger kid,
Yeah, because they make it sound like it's magic.
Yeah, it's intimidating, and if you go into it with a fun attitude and a positive, optimistic attitude, and I think you'll come out with it, something tangible.
Yeah. Is it dangerous? Sure. But if you follow the basic principles, you'd be perfectly fine and safe.
Well, that's why I started out with low voltage first and low current, very low amounts of power to get used to, how to set up everything, how to be safe, the one hand rule, all that stuff.
Half my systems, I can't even go high power because it just blows transistors. And I have lots of issues because it just creates so much.
Yeah, I can imagine. There's all sorts of, variables that you got to consider.
By the way, a simple suction fan is the same one they use for the laser cutter. It's an inline fan. So basically, you're going to connect one side of a flexible tube to it. You can go by your workbench. Then it's going to hook into the fan. Then it's going to connect that other side, and you put a flexible tube toward your window and just put a little board there or whatever, or 3D print something, and you can blow it right out the window. But that fan works perfect so that there's nothing getting in the air. And then if you have a giant space like mine, use a sucker fan, an attic fan. Just make sure it vents out to the street and not into your attic. But those are two ways to do it. But the inline fan is cheap, it's fast, and I think it's $40.
Nice.
Shawn asked to show the ground photo he sent.
Yeah, I'm in the right place. I don't know that I have it right here. Nope, that's not it. Nope, that's not it. This one?
Interesting.
And then the other stuff is going nowhere.
By the way, he says the path of least resistance goes towards the ground, but when you rewind the footage, the actual ground itself is pulling off the energy first, not the coil. So it's pulling, from the ground to the coil, not going back into the ground.
So the excess isn't going into the ground. The ground is feeding the coil?
Yes.
Oh.
So it's like
right? Like lightning, when it comes down, it meets it up.
Yeah, give me a second. I'll pull it for you real quick on the actual picture.
Yeah, that's a good analogy.
I think that's a lot of what we're doing. Because recently they found that out that when lightning strikes, it comes up to meet the bolt from up top, right?
Mhm.
Yeah.
So I kind of wonder when we send a signal down our ground.
I mean, it all boils down to the fact that the Earth is a giant magnet, right? And magnets have enormous amounts of energy that we can tap into.
Yep, you're not
So
wrong.
here you go, guys. So you look at there, he's got his Tesla coil running, his ground wires to the left, and you can see it's already pulling plasma out of the ground.
Oh yeah. Yeah.
So it's pretty clear which side it's coming from. Now, just so we all understand, they make earth batteries. That means they literally put stuff in the dirt and they make energy out of the ground. So it's telling you how it's pulling it. The Tesla coil is a pump. It's going to pull in with suction that, energy.
Yep.
So that's why it runs so much better when you put it into the ground versus having it not grounded. Well, now you know.
I hear you.
And that also why the grounding between two grounds is so important, because you're building the ground as a capacitor to the field.
Yep.
Now, that capacitor is to infinite size, isn't it, Gerald?
Yep. Absolutely. You're tapping the earth. How big of a capacitor is that?
Yeah.
Yep.
So I just have to say this, guys, and we'll take that off there so I can say it. You wonder why you get so much energy, okay, when I run my gravity flyer. Why I can break your numbers easily is because, one, it's cold. Number two, it's as much energy as I want. However long I run it is how much energy I want. Okay?
Yep.
That's the answer. You want to know where all the energy comes from? You want to do your multiplication on it? There it is. And I use the ground as a capacitor by double grounding.
Absolutely. But now, most people wouldn't understand that because their brain can't wrap around the fact that the ground is actually a source of energy.
Nope. Well, then let me take care of that for you. How about I put as much water as you want into a giant lake under the ground, and then I tap both sides of it with the power. Now what do I have?
Yeah, you got a giant water capacitor.
There you go.
Right?
I just ground. All I'm doing is grounding it, but I'm making a capacitor out of it because I can store energy there.
Which is exactly how I use the water for a ground. Why? How fast does the energy move between two capacitor plates? It's like, wow. So if you have a capacitor plate on one end of the lake and one on the other, it doesn't make a lick of difference because distance doesn't matter when it comes to the dielectric. So it's like, well, I mean, it does, but in that instance.
Do you want to increase your number? So here's the thing. When you put in 2 rods of copper,
yeah,
you get a battery. When you put in different rods, you get a capacitor, right?
Yeah.
So what do? We always go on the ground of our actual home instead of an actual ground. So when you actually get out to the field, how do you want to tap it? You want to tap it as a capacitor? You want to tap it as a battery? Which one are you looking for? Okay.
Yeah, it depends, right?
Yeah. So I tell you this because I'll tell you again what my front yard is. 3 inches of sand, 12 inches of gravel. Okay. And the bottom is always moist because it pulls in the water so that the moisture and rain times can suck into the bottom.
Oh, what I could do with land like that.
And it's this thing is 20 feet by 20 feet. So you can imagine I got a good base for whatever I need to do. And that's exactly why I use that instead of the backyard.
Makes sense.
It's all about that base, baby.
Yeah. I got a special place that I could do tests too, but it's only a certain time of year because there's a lot of people around there and you can't, to be safe, right? So, but yeah, that's awesome. You're in a good spot for that.
Yeah. Well, it's all my drainage. So it's a French drain is what they call it out here. So I got piping running in there. And if I really want to fill it up, all I do is clog the piping and run some water in there and then it'll remoisten the base at any time. So that's why I do it at night, because all the moisture pulls into the ground at night. So therefore, I get a higher field that goes on in there. If you do it during the day, the ground gets drier, and it'll actually not pull the field as well. So just something you should probably understand about the earth. Just in case you want to do something like this.
Absolutely.
You don't always want to use the wall plug ground. Let's just put it that way. It's great for the inside experiments, but when you get outside, do it the right way.
Changes. Yeah, then you can have real fun. Remember Tesla, what was it? He lit those bulbs miles away from the source.
Yeah.
So makes you wonder if that was part of it. In fact, I can say I know it was part of it.
Low frequency, high capacitance.
Yeah.
That's
Signal went for miles, right? What do they say? 1 hertz goes 21,000 miles in one shot.
Holy crap.
I think that's what it is. 1 hertz is 21,000 miles at the end from point to point. Depending, and I think there's an actual calculation of how much energy you have to use to get that to.
Oh, hold on. Joel Legacy brought this up about Tesla and the caves in Canada with the wire. Okay. And he was sending the energy from one place to the other, and they shut him down because of the power company out in Canada, right?
Yeah.
Now does it make sense?
Yep. Big time. Because they were underground. They were sending energy so fast, and it totally bypassed. Wow. That must have ticked them right off, eh?
Yeah. So I always hear, I was listening to Carlson. What's his first? I don't remember his first name.
Randall.
Yeah. So was listening to him, and he was talking about the pillars that are underneath the Great Pyramid, right? And he always says that they resonate and create this static, and it's like, no, they're grounding rods that tap into the water to the pyramid.
Multiple grounding.
Yes.
Yeah.
I can't say this enough. Take a Tesla coil out front, put the rod in the ground, put it on the Tesla coil. The frequency will drop. Use a Slayer exciter circuit. Use the transistor I told you to a couple videos ago. I'm telling you right now, your frequency drop is just amazing. Mm-hmm. And you can get that sucker down to about 12 hertz, sometimes 8 hertz.
Which allows you... Go ahead. Sorry.
You're communicating with the earth at that point.
Yep. That's exactly it, Nathan. You hit the nail on the head. That's one of Tesla's secrets.
Yep.
Literally. He drops his frequency down by using your method. Well, I'll call it your method. You're the only one that's ever described it in the last 12 years that I've been doing research online, and literally makes it so that it can travel maybe not 21,000 miles, but maybe 1,000, maybe 2,000. I'm not sure on the frequency of 8 hertz when it comes to distance, but that's...
Well, it also goes to what Jack said. Low frequency.
Yep.
Capacitance of the earth. You build that into your system, and you create your Tesla coil bubble with your scalar field bubble. Then you fill it up with the energy of the earth as you look at your gravity flyer as your capacitor, which most people think it's a capacitor anyway. So think of it as your capacitor, and you're simply filling your capacitor with the energy you want. Now, that should be the simplest thing in the world to understand, right?
Yep. We're
just simply double grounding and pull a capacitor. And if you understand it, it's simple. If you don't, you pull your hair out.
Yep.
I gave you the steps to get there. I hope everybody gets there and has fun. Okay. Just watch how long you run it. That's all I'm going to say, because strange things start to happen if you run it too long. Okay.
It affects the whole area. Right.
So, yeah, I like I said, my house started shaking a little bit, and it could have been anything else. Okay, I'll just put that out there. But it stopped when my experiment stopped, and it was my kids asking me, oh, what happened? I went, nothing. Nothing happened.
Regular earthquake.
Yeah. I don't think it went beyond my house. Let's just say it that way. It was just the local front yard that had a little issue than when you're tapping power. And watch what other fields are around you. I will say that, because the energy company taps the power probably about 40 feet away. So they tap into the ground. So you have to not let it travel any further, or else
You're getting some feedback that won't be nice.
no.
Yeah. You don't want that feedback.
I shut it down. I have a time limit, and that's it. There's a reason for that. And
Yeah, your bubble will keep growing if you reduce your bubble. Use a load. You can use a load to reduce your bubble and contain your bubble, right? That's how I actually, this new coil, I say it on the video. I'm using my load to control the runaway in my circuit because it's producing like 600 volts in a second.
hold on, what you just said, right? Use your load to control your bubble, right?
Yeah.
What do you think my gravity flyer is?
Yeah, I know.
No. So it's in the circuit as capacitance, but the other side of it is as the load. So it's acting as both, because when you put more wire to a Tesla coil, it acts as capacitance. But when you put the top on your Tesla coil, it acts as a load. But we're completing a circuit through a double ground. So I'm getting capacitance and a load at the same time.
Yeah.
It's whatever. You guys are all figuring it out at some point.
It's almost like there's AC and DC in the circuit.
Yeah, pretty much.
You know what I mean? Yeah.
And you're taking advantage of both systems.
Absolutely. That's how you're able to close the loop or open the loop, whatever you want to call it.
It closes when it's full, and it stays open until it does.
Yep.
And that's just the way it works. Okay, sorry.
And you can never get too much. It'll give you what you need. And if you get too much, it'll just blow your stuff and it'll stop you. But if once you get it going, you just use that load to bring in as much as you want. Or
it tells you, because it'll actually start vibrating in a way that shows you it's ready.
Yeah.
And not a lot of people know that because they haven't gotten to that stage of it, but I'll leave that for another day. It tells you when it says hello.
Absolutely.
And it's just, I don't know. I guess it's one of those things where if you invent things and work on things, you have a total different understanding of this than if you just do the math on things, because the math, it lies to you a little bit, because if you use an algebra, you're making an equation equivalent to the other, right? So X always has got to equal something. Well, that's a problem, and that's not good. You don't want that. Sometimes you want geometry, because then one is an expansion equation like geometry is. It's always about expansion in one direction, or two or three. So that's my thing. And then when you get into the higher math, sometimes they do a little bit of both, but they are very skimmy on the geometry. They have one excerpt of geometry while the rest is all equalization. And that's why they make the mistake of thinking this can run in reverse, and they mathematically say it's proven when it's actually not, because it cannot run in reverse without an extra feature added to it. And you'll only know that if you build it. So I think that's where the two have to start to mesh. And
I agree.
I'll say this to anybody out there that actually wants to come on any one of our shows. I'll talk to anybody about physics if you'd like. Send me your paper a week ahead of time. I'll study it. I'll learn it, and then we'll talk about it. And
that's the way to do it.
I won't assume or do anything. I'll just promote your paper. But I'll tell you, we'll know the difference as soon as we see the experiment. And if it's proposed, I could tell you this panel will tell you if you're on the right track or not.
Sign me up for that physics class.
There's been so many experiments, and we all collectively do so many experiments that, you know what, you can tout whatever you want to tout. Unless you've actually done the work, you're really not going to know. I don't know how to put that. I mean, the math is one thing, right? And it'll get you to the position in your mind where you know where to jump off of, so to speak, in order to get into this. But ultimately, it comes down to experimentation, right?
Yeah.
Unless that have done it are teaching you. Go ahead.
No, I'm sorry. I was just going to say, by the way, Shawn, I did film it. And I do have it waiting in the wings. I'm waiting for a little more time. We have some other things to get through before I start showing those things.
Yeah.
So I think I'm probably about a month and a half out, then maybe a little bit more time after that, somewhere there. And then, but
yeah,
Gerald shows his stuff on Sunday. Mike's going to show his stuff probably Saturday or Monday or the next week. That's going to be cool. And then we're rocking and rolling, man. And then when Gerald's done, by that next week, I'm going to premiere a video based on what he's doing and fill in the rest of it. Now, I'm going to warn you ahead of time. There's going to be parts that are censored. There's nothing I can do about it. I have to build them in there, but then I have to cut parts of them out, and I'll let you know, hey, this next part's censored, and I can't show it on YouTube. But
go ahead.
No, I was just going to say, we will find a way to get the whole thing out there after that.
What I've done is, and this is the part I'm kind of working on right now, is the thing that we can't talk about because it's censored. I'm leaving that as a part 2, and it's going to be on that other platform so that if people do want to view it, it is a key part to my research, and there's a lot of it there. So it'll be part of that, and then people can look at it and view it there, because I don't think Tube will allow us to,
No, they won't. Then there's no good way to present it that they will without them taking offense to what we're saying.
Exactly.
But I want to make sure it all goes out together. So like, you give yours, I'll give mine, then we'll all combine into a third one where everybody chimes in and stops the video. Hey, this is my aspect to it and this and that.
Absolutely.
And I think that's the right way to go with it. Yeah. And based on what yours is, I'll show you what I have on it, and then you can tell me where I need to adjust it.
Okay.
So the second one may actually turn into the third one, and we'll just, because let me tell you, the levels that I've thought about this thing and put it all together is absolutely mind-blowing. And the video, it's like a narration of how it works, and you know what I mean? The individual steps, and how you'll see one thing and then the next thing will go right on top of it. And by the time I'm done, I'll make them $1.
Yeah.
And it'll drive you absolutely nuts how I knew that. So, and how I just figured out every single part of this. You could try to tell me I'm wrong, but I know the parts of it. So it's just
and that's awesome. If I went back to the history from my research and when I started and me studying Mandelas and stuff, all of it, man, it would be like a 2-hour presentation. And I just can't, I don't have the patience. And I'm sure other people don't either. So I'm trying to reduce it to like just a small size, but not too small, enough for people to understand.
Gerald, like long term, not anything that's going to happen soon, but if you want to work with me on some kind of like documentary, like a proper, produced video on your theories, that's something I think we could work together and put out eventually, for your channel.
Definitely, I'm into that. I also still have to contact Joe. I've got this wicked speech I want to put music to, but I just haven't been able to get the time to contact him and do the music thing that we talked about. So,
real quick, I want to make sure before we're done with all of it, we have the correct theories in the right place with the correct math, and they'll never be able to take it away from you once it's done.
Yeah.
If that makes all the sense in the world when it comes to physics, you're going to be plagiarizing the whole time if you even try to come near this. So you can write a paper based on it, but then you're going to have to give Gerald all the credit that he deserves.
Well, I'm sure they'll find a way of doing their thing. But you know what? I'll throw it out there. We'll do the best they can, and you can either accept it or not. And
I just don't think they'll understand it. Even with every bit of information, I don't think it, because they can't build it.
Well, they won't accept it.
Well, either way, it'll be out there, and then the people that hang out and watch our channel, They'll understand it. They'll know it. They'll be able to build things like this. The other people will just be lost. And I would hope everybody would get on board with it, but you can't do anything for anyone else,
Yeah, but it's got to be put out there because there's lots of people now finally looking into free energy, trying to prove it or disprove it one way or the other. I don't have to disprove it. I want to share it.
I think that there's one person we can get a hold of that will actually push it to where we want it to go.
I think there's a couple, but the one of them I think it's going to take some showing of experiments. Maybe. Go ahead.
I think all of it will.
Yeah. I wish I could travel. If I could travel, this would be so much easier. I'd be in California right now, and I'd just be showing you, right? But I'm stuck. My bad decision making as a kid kind of poo-pooed on that, right? So, but yeah, that's actually.
We'll come visit you, Gerald.
Well, see, there you go, and that's one of the downfalls of proving this tech is because I can't travel. I can't go to Los Angeles or who knows, Washington or wherever. I can't.
Wait, you need a team to represent you if you need to do stuff like that, and
That
that's
would be cool.
yeah.
Well, I'll tell you this right now. I'm not coming out in the winter. It's got to be summertime. I'm not dealing with that cold.
It's only minus 35 Celsius.
Oh,
You can make it, Nathan. Don't worry. I only almost died once.
He'll keep you warm with the coil. He'll build one into the lab coat.
oh my God, dude. I got a lot of fat as insulation, but it sure doesn't help the bolts in my back. They hurt,
no.
man. Not in the cold, they hurt.
Yeah, that would actually, coming up here like that would hurt. Definitely. I go to a nicer place if that's what it took to meet you guys, where it's warmer, like Toronto or Vancouver or something. I don't know, whatever. I can travel anywhere in Canada.
Oh, well, Canada's fine, dude. I'll go to Canada. Go where you are. I come sleep on your couch, man, and say hi to the kittens and hang out for a month and then leave.
I'll put you up in my man cave in the garage.
I'll have to go to work over at Gerald's house.
Yeah.
Like a mule. They'll be whipping me. Come on, Nathan, get it done.
Get to work.
Oh man, it's so fun. All right, guys. We have to cut out. It's about that time. So guys, you got anything going on that you guys want to talk about?
Go ahead, Ben.
So I'm gonna get together with Michael on Saturday, and we're gonna do a pre-recorded session going over all the updates for his circuit and his coil research and how it connects to mine. So I don't know if it's gonna be released Saturday, but expect that sometime soon.
Nice.
Very cool. Yeah, for those of you who don't know, Michael was from England, and he's working on the rodent coil.
Nice. For me, might show another coil. I got a couple of videos coming out on this new coil that I just showed off. It's actually called the lens. There's a reason for that. We're going to get into lasers in the future, everybody.
Nice.
So there's that. The sphere is going to come out soon. It was a very difficult build, and the copper tubing is almost complete. So I got some updates coming up. Yeah.
Very cool. All right, with that, guys, like I said, Gerald's on Sunday. Okay, we're not letting him out of this one. So, and then we'll be on with Mike on Friday.
There you go.
Awesome.
All right, guys, have yourself a great day. I appreciate everybody being here. I appreciate the chat. Thanks, guys, for coming in.
Yeah, thanks, Nathan and Gerald. Thanks, chat. We love you guys.